Hello, 8th grade students. Today we're going to look at um, lesson 4 of module 7, and it's called Equations with Many Solutions or No Solution. So let's just take a look at what we're going to be talking about here. We've been talking about solving equations and inequalities in the last couple of modules. And today we're going to look at an equation and determine the number of solutions. And it says, so far, when we've solved a linear equation with one variable, we have found that x, or whatever variable they're using, makes the equation a true statement. When you simplify some equations, you may find that they do not have just one solution. So let's talk about this. When we solve an equation such as x plus 7 equals 15, and we solve that, we can subtract 7 from both sides and we get x equals 8. Okay, and we see that there is one solution for the value of x. That will make this statement true. And we know that because if we plug this value back into the original equation, and we can check to see if it's true. So instead of x plus 7 equals 15, we will plug in 8 for x. We will add it to 7, and we will see, does it equal 15? And yes, it does. 15 equals 15, and yes, we have a true statement. Okay, so that's basically what we've done so far with solving equations and getting one solution. Another form of an equation that we're going to be looking at is some equations will find that any value of x will make the equation true. And that would be something like x plus 7 equals 15. It could be instead of just 8 making it true, it would be anything. You could plug in -2, you could plug in 1/4, you could plug in 5.3. Any number for this value of x would make the statement true. And when that happens, we're going to say, instead of just one solution, we're going to say there are infinitely many solutions, because remember, our number line goes in both directions. We have 0 here, we have positive numbers here, and we have negative numbers here, and it goes on to infinity and beyond. So if you get a solution where a specific number equals a specific number, and that would look like something like 5 equals 5 at the very end, whereas in this one we got x equals 8. So if you come up with you solve the entire equation and it looks like a number equals that same number, then we know that any value of x will make it true, and there are infinitely many solutions. Finally, the last type of equation we are going to get is when one number equals a different number, and it's not the same number, it's a different number, and that could never be true. And for this one, an example would be 3 equals 2. Okay, 3 never equals 2. It cannot happen. So if you get something like this, a number that equals a different number at the very end, then that means there are 0 solutions. No value of x will ever make that equation true. So those are the 3 different number of solutions that equations will have. They'll either have the one standard solution, they could have infinitely many, or they could have no solutions. So let's look at some examples here. In example 1, part A, we're going to use the properties to simplify each equation. And they did it for us, and this is what we would do. We would say, okay, to get rid of this 3, we need to add 3 to both sides. We would then get 4x equals 2x plus 16. We then would need to get rid of the 2x, so we'll subtract that. And we get 2x equals 16. We need to get rid of the 2, so we divide, and we get x equals 8. So again, this is like our very first example. There is one solution to that equation. And that's basically what we've been doing so far when we have the same variable on both sides, and we combine them to one side or the other. All right, so let's go to the next page, and we will look at part B. Part B, we have the variable on both sides. The first thing we're going to need to do is distribute the 2. So I guess they're doing it this way. The 2 times 2x is 4x. The 2 times -1 is -2. So they've dropped down everything else. The next thing they do is combine like terms on this side, and they get 4x minus 5 equals 4x minus 5. Okay, you can kind of see that these two expressions are the same right here, right? But if you don't, then you would subtract 4x on both sides, and these two cancel out, and these two cancel out, and what do you have left? You have -5 equals -5. Okay, so the same number equals itself. There are infinitely many solutions. And then finally, part C, we have an equation here, 4x plus 2 equals 4x minus 5. And we just start by getting rid of the numbers, and we'll get the variables on the other side. So we're going to subtract 2 on both sides. We get 4x equals 4x minus 7. We need to move this variable to the other side by subtracting. And we end up getting 0 equals -7. Well, 0 can never equal -7, and that means there is no solution. So that's part C. Those are 3 different examples of how you would get the different number of solutions with the equations. And the reflection question says, well, what happens when you substitute any value for x in the original equation in part B? So in part B, if you substitute any value for x in this original equation, so I'm going to say 4x minus 5 equals 2 times 2x minus 1 minus 3. And I can choose any number to plug in for x. And remember, there are infinitely many solutions. So I can choose any number. I'll choose 10. So I'll say 4 times 10 minus 5 equals 2 times 4 times 10, or I'm sorry, that's 2 times 10, minus 1 minus 3. Well, what are we going to get? Let's look at this one. 4 times 10 is 40, minus 5 is 35 on that side, equals 2 times 10 is 20, 20 minus 1 is 19, 19 times 2 is 38, and 38 minus 3 is 35. So we get a true statement. 35 does equal 35. And I did this by plugging in 10. Now, if you choose a different number other than 10 and do all of the calculations, you should get this one number that equals itself. Okay, so what happens, let's go back to the question, what happens if you substitute any value for x in the original equation in part B? In part B, you'll get a true statement. Okay, if you plug in anything, you will get a true statement. And then the next part of the question says, in the original equation in part C, what happens when you plug in any number? Well, remember, there is no solution. So it doesn't matter what number you plug into part C, you are not going to get the proper answer. And you can test it. Let's test it by plugging in 0. So I've got 4x plus 2 on this side equals 4x plus, or minus 5 on this side. So I'm going to plug in 0. 4 times 0 plus 2 equals 4 times 0 minus 5. Well, any number times 0 is 0, so I have a 2 here. Any number times 0 is 0, and I have a -5 here. Does not work. So the answer to this question in part C is you will never get a true statement. Okay? All right, so let's take a look at your turn. They want you to use the properties of equality to simplify each expression and tell whether the equation has 1, 0, or infinitely many solutions. So the properties of equality just say whatever you do to one side, you have to do to the other in order for them to be equal. All right, so let's start with the left side. To get rid of the 1, we will subtract 1. We have to do that on the other side too. So I'm going to rewrite what we have. We have 2x by itself over there equals 5x minus 9. Because remember, negative 8 minus 1 is really adding the opposite, and you get negative 9. Okay, I'm going to subtract 5x to get that on the other side. And I'm going to have negative 3x equals negative 9. And then I have to divide by 3. And I'm going to end up getting x equals a positive 3. Negative 9 divided by negative 3 is a positive 3. So I found that x equals 3. Tell whether the equation has 1, 0, or infinitely many solutions. This equation has one solution, and it is, so I didn't spell that right. Oh my goodness. Let me try this again. Solution. Okay. And the solution is 3. So let's try number 3. I'm going to distribute the 3. So I've got 12x plus 9 minus 2 equals 12x plus 7. So if I combine like terms over here, I have a positive 9 and a negative 2. So on the left side, I'm going to have 12x plus 7 equals 12x plus 7. And if you can see it right now, you can stop here and say, well, there's going to be infinitely many solutions because whatever you plug into here, it's going to be the same on the other side. However, if you cannot see that, we can still move forward and subtract 12x, subtract 12x. We will get 7 equals 7. And again, when you get the number that equals itself, that means there are infinitely many solutions. And that's how you say that. You don't say any number will work. You say that there are infinitely many solutions. So I'm going to guess that this one is that there are no solutions, but let's look at it, okay? So I have 3x minus 9 equals 5 plus 3x. So I'm going to add 9 to both sides, and I'm going to have 3x equals 14 plus 3x. I need to get rid of this 3x, so I'm going to move it to the other side. 3x, well, 3x minus 3x is 0. And what I have left on the other side is 14. So 0 never equals 14, so there are 0 solutions. All right, so if you got lost when I was doing any of that, go ahead and pause the video and go back to that so you can follow along. And in the meantime, I will move forward. So the next example, we're going to talk about writing equations with a given number of solutions. And it says you can use the results of linear equations to write an equation that has a given number of solutions. So let's take a look at what we're doing. They want us to write a linear equation in one variable that has no solution. Okay, so you're going to start with a false statement such as 3 equals 5. All right, we're going to work backwards basically. So if you come up at the end of your equation after solving it and you have 3 equals 5, you know that is not true. So you know there are no solutions, right? So to write an equation, we're going to work backwards. We're going to start with the answer. And then it says add the same variable term to both sides. Okay, they started with 3 equals 5. They added x to both sides. All right. You can't add x to one side and 3x to the other because that won't work. It has to be equal. Next, add the same constant to both sides and combine the terms. So in this case, they used 7. 3 plus 7 is 10. 5 plus 7 is 12. Verify that your equation has no solutions by using the properties of equality to simplify your solution. So basically, they subtracted x from both sides, and they got 10 equals 12. So they want, and our reflection wants to know, they want us to explain why the result of the process above is an equation with no solution. Why is that? Well, we started with a false statement, right? Okay, so I'm going to write this down. We started with a false statement, and then we used properties of equality to keep both sides the same. All right, and basically that means whatever we did to one side, we did to the other. So if we start with a false statement, we're going to end up with a false statement if we do the same thing to both sides. Just like starting with a true statement and adding or doing the same thing to both sides will keep it a true statement. So now they want us to do our own. They want us to complete each equation so that it has the indicated number of solutions. So they want us to have no solution for this. We have a 3x plus 1. So we can choose, because we have the same variable, we have the same coefficient and variable on both sides, we can choose any number. We could choose -5. We could choose 14. We could choose 526. It doesn't matter what we choose on this end as long as it is not 1. No, you cannot use 1. Okay? If you use 1, then they're going to be equal on both sides. Number 7 says, finish the equation so that they have infinitely many solutions. Well, that means both have to be exactly the same. So if you have 2x minus 4 on this side, you must have 2x minus 4 on the right side. Okay, so it's kind of opposite of no solution. So that's our lesson for 7.4. There are some guided practice problems that you will need to do. So go ahead and take a look at those, and please do the work on your own the best you can. Then check your work. If you have questions, make sure you write them down or highlight them so we can go over them in class. I hope you guys have a great day.